Hi friends, today welcome back. We're going to be talking about volume of shapes, and I want to start this conversation by just making sure that you understand the different shapes. For example, we have here a bunch of prisms and a bunch of pyramids, and I want you to see how these prisms and these pyramids have the same base, but that their differences are in the shape that they're making at the top. So this guy right here, do you see how it's a triangle? This would be a triangular prism. Even though there's going to be a bunch of rectangles on it, we find the shape that's not the rectangle and we say that's the shape of the prism. So this guy right here is a triangular prism. This one right here is a triangular pyramid because it comes to a point. This one, we've got a cube or a rectangular prism. If one side was not the same as the others, that would be a rectangular prism. In this case, they're all the same, so we call this a cube, but another name would be a rectangular prism. This is a rectangular or a square pyramid because you can see the base matches the base of this guy just like it did on our triangle one. It's just that this guy comes to a point. Our pyramid comes to a point. So the next one we have is this hexagon. You can see, again, there's a bunch of rectangles on here, but we look for the shape that is not the rectangle. So we look for like the hexagon, in this case, that shape there, and that's what we call it, a hexagonal prism. This would be, you look at the base here, it's a hexagon. It's a hexagonal pyramid because, again, it comes to the point. So we're going to start with these prisms here. And the way that you find volume with a prism is base, the area of the base, and let's write that down. Volume equals the area of the base times the height. When you see a capital B, that means area. That means the area. Now, base can be a little bit tricky because what we have are a bunch of bases. Sometimes you'll see, for example, in this hexagonal prism, you'll see it drawn on a paper and it's laying on its side like this. And so you can kind of see that 3D shape laying on its side, and you look at it and think, oh, well, it's got a rectangle, so therefore it's a rectangular prism. What you need to look for are the shapes that are not rectangles, unless, of course, it's a rectangular prism. If they're all rectangles, then it's a rectangular prism. But you look for the shape that is not a rectangular prism, and that is your base. Your height is the distance or the length connecting those two right here. So be very careful about that because sometimes it can be straight up and down like this. Sometimes it can be on its side. I'm trying to tilt it so you can see how it would look on a piece of paper if it was drawn 2D. So the same with this guy. If we look at this one, it may be on its side like this. And so we see that it is a triangular prism because there are two triangles. But even though it's on its side, this is the height that connects those 2 points. So that would be our height, even though it's laying on the side. Up here, it could be its height when it's standing straight up and down. Okay, so let's talk about how you would find, so really what you need for volume is going to be finding the area of the base and times it by the height. Now let's touch base first on those pyramids too, or second, I should say, on those pyramids. So again, these pyramids, I lost my little triangle, boo. All right, so here we have our pyramids, and they all are connected by triangles. You can see all of these have triangular shapes on the sides. What's really important here is the base, which generally is on the bottom when we're talking pyramids. The base shape is going to be our big B. We're going to find the area of that guy, and then we're going to multiply it by our height, which again is going to be not the slanty bit, but the height that goes straight up and down. So on my triangular prism, I can take this guy out like this, and I can say, okay, so the height is what goes straight through here. The slanty bit is what we call our slant height. I know, super creative. But the height of the pyramid is what goes straight up from the top, straight down, creating a 90-degree angle. Okay, so how does this all apply? Well, then in order to find the volume, and before I go on, volume for pyramids, I don't want to forget that part, is the same as the volume for a prism. So these guys are for prisms, except the volume for a pyramid is going to be volume equals the area of the base times it by the height divided by 3. Now that's because if I took this triangular prism right here, and I took, or I'm sorry, that was a triangular pyramid, and I have here's my triangular prism, okay? Here is my triangular pyramid. Envision if this was filled with water and we dumped it into the triangular prism. It would take 3 of these pyramids to fill up this prism. So the pyramid is exactly 1/3 of this prism. That's why we divide by 3. Okay, so let's talk about how we're going to, let's talk about some formulas that are going to be really helpful for you for finding volumes of pyramids and for prisms. So for the volume, so first make sure that you're writing down these formulas. Then let's talk about some common areas for finding the base. So let's say area. So we know an area of a rectangle is going to be length times width, or length times height. You may hear it referred to as that. The area for a triangle is going to be the base. And notice I used a little b. That's because when we use a big B, it means area, times the height. And always it has to make, so it's going to be our height, it has to make a 90-degree angle. You don't want to use this slanty bit on the side when you're finding the area of a triangle. That's not helpful. So for our area here, we've got area equals length times width. And then the area for a triangle is going to be base times height. However, we cut it in half. And that's because, let's say we have a square here, and let's say that the area of the square is 25. If I cut it in half, that means each of these are 12.5 because, and you'll notice now I've drawn a triangle. That's why we cut it in half. Okay, so we've got the area of a triangle. Now, it may not be this soon that you're learning the area of other shapes like hexagons and other polygons like that. However, so let's actually talk about circles. I forgot that one. Circles. To find the area of a circle, the way that I remember this, remember your radius, it goes from the center outward and it can go anywhere on the circle. Your diameter is all the way across. That's going to be your diameter. So it's 2 of your radii. You take the radius, double it, you get your diameter. The way that I remember circles, I remember the circumference is cherry is delicious pie. And then area, I remember apple pies are 2. So to find the area of a circle, you would take the radius squared and multiply that by pi. And we do have circular prisms. We call them cylinders. It's think of it as a can of soup, right? So this is like a circular prism, but we call it a cylinder. And again, though, you find the area of the base here and you multiply it by the height that's connecting those 2 things. Okay, hopefully that helps explain those. If you have any questions, let your teacher know. Otherwise, we will see you next time. Thanks so much for joining us.